Hello, this is an example of doing a site reduction, celestial navigation site reduction of a star using our StarPath work forms and publication 249, volume 2 and 3. So if we're doing a star that way, that means its declination has to be less than 29 degrees. And so that's what we're going to do. We're going to do an example of, what is it, Regulus. And so here is our textbook on the subject, and then here are the forms. And you can download these forms here. If you just click this button here, you come to the forms, and then you can see what the forms look like. And that's a free download. You can download that. Now, these are just the forms. They don't have instructions, but we do, in fact, have a book that explains the how to use each, several samples of the forms, plus, more important, very detailed instructions and examples using the forms. So that's what we're going to do, and that's the forms we're going to use. And so they look like, okay, I think that's all I need from this. Now let me see to what extent this works. Okay, so here's a camera. Oh, I don't think I need a keyboard. I don't need a keyboard. Let me put that over here. So here is the form we're going to use. And then here's an example of the site. And so I have a pencil, and actually a pencil and a ruler. And I have one of these forms. And so here's the site. A watch time, 19 hours, 48 minutes, 58 seconds. And that watch is set to zone description +8. And it's 7 seconds slow. And the date is 27 March that. The DR position is here, 45 that. Height of eye, 9 feet. Index correction, 1.2 off. And that's what the sextant read. No corrections made, sextant read. So that's what we start out with, and then we would fill in the form here with the watch time. That's 1948. You just put that 1948, 58, and then our watch error. The watch error is slow, so we have to add +7. That would be here. And then the zone description is a west longitude location of the watch +8. And again, we're stressed that I didn't even say that correctly. We always refer to the zone description of the watch, so it doesn't really matter where it is. This is the zone description of the watch itself. Now I can just add these up, and it's 15. 65, 48, and then 18, 16, 17, 27. And then this would be, if I take away 24, then I've got 03, taking this guy over here, 49, and then 05. So I've taken these 60 seconds, I've added 1 minute here, this was 27, so that was that. But now, look, when I took away that 24, that means we're actually 27, we're 3 hours into the next day. So our date was the 27th, so this is now 28th March. And this is just a space in the form to make a big label if you want. And that's a Regulus. We're doing the star Regulus. Okay, and the date, well, now this is again the watch date up here. So this is 27 March 1981. And then the body was Regulus. And the height, HS, now that's a sextant height. And that was 40... what was that here? 42 degrees, 58.5. 42 degrees, 58.5. The index correction, what was it? 1.2 off. So the rule is if it's off, you put it on. So that would be plus 1.2. And now the dip, we have a height of eye was what? 9 feet. 9 feet. Oh, okay. So the first thing I guess we have to do is look that up. I didn't. I know the answer to that, so that's why I didn't even think to put it up here. Let me just see where that is in the almanac here. It's 2.9 feet. Let's see. Oh, hey, here we go. Dip. That's in the front. This is a 1981 almanac. It turns out all the Coast Guard tests are 1981. So we even sell these almanacs, but that's easy to find everywhere. 1981 almanac. And so here you've got, what do we have? 12 feet. So you go feet here, 12 feet. 12 is between, let's see, 12 height of eye. No, wait a minute. We don't have 12 feet. We have 9 feet. 9 feet is between 8.6 and 9.2, and then over to the left, that's minus 2.9. So 2.9 is the dip. So that is 9 feet, and this goes to minus 2.9. Now we can get the apparent height by just, now, in what order you fill here doesn't matter, but in this case I'm right here. So I might as well do these. Now, sometimes you might just take a calculator, 58.5. If you're tired and, don't trust your memory, 58.5 plus 1.2 equals minus 2.9 equals. And then you get a 56.8. Now, it depends, sometimes if you're tired and bouncing around, a little calculator for even a simple math like that could be helpful. What do I got? 56.8. That's the apparent height. Okay, now what do we have over here? GHA. Oh, this is a star. Okay, so this is a star. So we don't look up the if it's a sun, moon, or planet or something, we look up the GHA of the object. But with a star, we actually look up the GHA of Aries. And then we do it first for the hour. What's our hour? 03. So we got 03 hours of Aries on 28 of March. 03 hours of Aries on 28 of March. Now, you go in the almanac to the daily pages, and this is March. See, these are the daily pages. March, three days per page. March 28 is down here at the bottom, and we want 3 hours. 3 hours, and so here is the value, 230 degrees, 26.8. Right, and I'm double checking, 230 degrees, 26.8. So that would go here, 230 degrees, and this was 26.8. Okay, now the GHA again of Aries, and we want minutes and seconds. That's 4905. So this here is 49. I can remind myself here like that if I want to. 4905. And so we would get that probably from the back. Yeah, from the minutes and increments in the back of the book. Let's go to 49, 48, 49. Here's Aries. This is 49 minutes and 49 minutes and 5 seconds. It looks like can you see that? Oh, yeah, Aries. It's 12 degrees, 18.3. 12 degrees, 18.3. And that goes in here. 12 degrees, 18.3. Now, this next line, it says here, SHA, it's a plus SHA, or if it's not SHA, it's for the star, or it's a V correction if there's moon or planets, but we don't have that. We have a SHA for the star. So let me go back. Oh, my thumb's in the right spot. That's good. Now we need to know the SHA of that star. Well, we're also going to need to know its declination. And what is the star Regulus? Let me get where's my counter here? Okay. the list of stars on the daily pages. Now, they don't change much, but they change a little bit, and so that's why they put the stars every 3 days. There's 3 days for a page, there's all these stars. And so then we want Regulus, and that's Regulus here, and we see, if you can see that, 208 degrees 9.4. So that goes in here. 208 9.4, like that. And then let's get the declination. The declination of Regulus is right there. And you see it's north 12 degrees 3.5. That's it right there. North 12 degrees 3.5. Okay. So this is a declination of north 12 degrees 3.5 minutes. Now this is a D correction, but the stars don't have a D, so you could cross that out. They don't vary. Moon and planets and sun, they would, but not here. And then this is HP of the moon, and it's not a moon, so that's that. Now what's next here? Oh, okay. Now we can sum these up. Again, I might get we're going to sum these up here. We got the hours part, the minutes and seconds part, and then the GH, and then the SHA. So the way we do the GHA of a star is we look up areas, then we add the sidereal hour angle. So we have to add all three of these. So I'm going to go here. I've got 230 plus, 12 plus, and 208 plus. So that is 450. And then here I've got 26.8 plus 18.3 plus 9.4 plus. And here I have 54.5. 54.5. Now we do our assume longitude, and it's going to, the assume longitude, we want it to be near our D. Oh, I didn't write the DR. Okay, I'm back to my, let me fill, I didn't fill in this form up here. The DR latitude was 45 degrees 21 minutes north, and the longitude 130 degrees 03 minutes west. Okay, good. Well, normally you'd have log readings and so forth. I'm going to let that go for now. So we want to choose the assumed longitude as close as we can to this one, but it must have the same minutes as this one. So that can't be 130. It would have to be 129. Okay, 129 degrees, and then 54.5. So these have to be the same. That's a reminder here. In the west longitude, you're subtracting these, right? It's a minus. And so these have to go away. That means they're the same. If you're in the east longitude, like this is east, then you have to choose, this is a plus, you see plus, then these have to add up to 60, which that makes them go away again. It just adds 1 degree. And so the point is that we look here, look at this comparison just to be sure we have the right assumed longitude. This longitude has to be as close as possible to this one with these two the same. And the hint is you can always get it within 30 minutes. That's not going to be a problem. 30 minutes. But if we look here, 129, 54.6. So that's like 5.5. That's only 8.5 minutes away from this. If we had to put 130 here, we'd have been way up like 50-some minutes. So 129, this is the right one. We have exercises in the book and in the classroom where you practice that. Now we just subtract these two. Let's see, 450 minus 129. Whoops. 450 minus 129 equals. This is now 321. Okay, now let's see, do we have everything? D correction. There is no D correction for stars. Stars, you know, the other bodies, the declination changes a little bit each hour, but not stars. They change over the years or maybe sometimes months, but so there's none of these. So this declination is just still the same, 12 degrees 3.5 for a star. That would be that way. Oh, this box here, see, this is for 229. This little box here is only used if we're using 229. We are using now 249, so we don't use this at all. Okay, this box here now, we're just summarizing what we've done here, so we can go in the site reduction tables. That's a Public 249 volume 3 here. It has latitudes 39 to 89. Again, that's only, you see, only declinations 0 to 29. So this star, the only reason we get to do this star with this table is because its declination is in that range, 0. If it's outside that range, we have to use a different set of tables. And we cover that in the course. There's many kinds of tables. So the LHA, we're just doing a summary. We're just gathering stuff up here to make it easy. That's 121. The declination degrees is 12, and it's a north. And then the A latitude degrees is 45, and it is a north. And the idea here is we want to see that these are same name. They're both in the northern hemisphere or both in the southern, as opposed to contrary name where they'd be in the opposite hemisphere. Okay, so there we go. And now we're ready to go into these tables here. And we want to go, and you see, first of all, with these tables, if you look, let me go see if I can get it on here. You can see it. They go different latitudes on different pages. So we want to go to 45. And then once you get to 45, we have to find declination 12 degrees with same name. So then you look at the top, and you see here we got 0 to 14, same name. So that looks good. That's a good candidate. And the same way down here. But then we need LHA 321. So you get LHA 321, and you can get that on either side. You see LHA over here, LHA over here. You find on either side, it doesn't matter. And so let's see where it's going to be here. 3. Oh, there it is, 321 and 12. Well, you don't quite see it. Okay, there's 12 degrees, and there's 321. So here's what we got. We got the HC, calculated height, is 43 degrees, 12 minutes, and the D value is 47. 43 degrees, that goes here. 43 degrees, 12 minutes, and the D is 47. We have to deal with the sign. And the Z value, 321, 12. Z 122. 122. Now the D is plus or minus, but here's the way that with this table here, if it's plus or if it's a minus, it'll have a minus. Then there's no minus, so this plus. That's telling us how the HC changes as the declination goes up a degree. And you see, let's see a negative value here. Okay, see, when you get down here, then the HC is negative. No, excuse me. The D, I need a D value. HC negative, that means it's below the horizon. That's not what we're talking about. I want a D. D is the middle column. Okay, look over. You see, here's some down here. Here's D's minus 43. So when that's minus, that'll be a minus. So that's a plus. No problem. Now, the declination minutes is 3.5. And then the D correction the D correction, that's in Table 5. Now, okay, so here's an interesting thing. It actually came up in class the other day. Table 5, let me show you. Here, Table 5 is in the back of the printed book. But in the course, when you go back and download the PDFs of the site reduction tables, then that Table 5 is in the front. So we have to be careful. I think in the book, in our textbook here, we say it's in the back, and now we had to go and make some addendum and say, well, it depends. If you're looking at the PDF version, it's in the front. But it's in the back, and let's look at this table. We have D is 47. D is, now if you look at this table, this kind of notation up here means D is it's meant to be D is at the top and the minutes go down. Minutes go down the side. It turns out it's a perfectly symmetric table, so it really doesn't matter. But so we've got D equals 47, that's right there. And then we've got the minutes. Now let's look at this let's look at the minutes here. You see, when the minutes, D is 47, so when the minutes is 3, it's a factor of 2, it's a correction of 2. When the minutes are 4, it's a correction of 3. So if the value is 3.5, then this is 2.5. It's a very simple, you just can do that interpolation that way in your head. And so there's that. Now, this is a D correction. That's a plus. That's a plus. So this is a plus, right? This is the same. What we do with this is what we do with this. That's a plus, that's a plus. So here we've got the answer, 14.5. And then this is, so that's 43 degrees. That's 43 degrees, 14.5. Now, let's just finish this up. What do we have over here? So that's the HC, the computed height. In other words, if you were really at this assumed position right here, assumed latitude, assumed longitude, if you were really there at that time, that's the height you would see it. Now, additional, let's see, altitude. We've got additional correction for the Moon, Mars, and Venus. That's not there. Additional altitude correction. Now that's got to be refraction. So that's going to be true for everybody, every site. Upper limb of the Moon, there's none of those. So refraction for the stars, that's only refraction. Altitude correction. Oh, let's look here. I'm in the front of the printed almanac here. Altitude correction, sun, moon, and stars. That's for heights, HA, 0 to 10. That's wrong. Altitude correction, 10 to 20. Oh, okay. So, here we go. Stars and planets, altitude correction. And what's our height here? 4256. There, can you see that? But anything between 42, 44, and 45, 36 is a minus 1. And we have 42, 56. So that refraction is a minus 1. Minus 1.0. So now our HO is 42 degrees. One from there, 55.8, 55.8, and then the away and the HC value, I'm just rewriting this over to here, 43 degrees, 14.5. Now, the A value is the difference between those two, right? And so, 42, wait a minute, what did I do? 42. Oh, no, that's right. Oh, you know what? I think the easiest thing here would really be, if you're going to do the math, I would, you see, you really want those degrees to be the same. So I would just write this. I would write this a little. Let me see. There's this kind of rule. This comes in handy. I'm going to correct myself. I'm going to call that 42 degrees, and I'm just going to add 60 to this. So this would be 74.5. Okay, so now the degree, see, I've got to subtract those two, and so those degrees are the same. Now I subtract these two, 74.5 minus 55.8 equals 18.7. 18.7, and the rule is calculated greater away, so that would be, let's see, calculated is greater, so this is away. So, and now the Z, okay, so this is, that's a label, calculated greater away, or in our form, you take the label next to the biggest one. So you don't even have to know calculated greater away. You could just say take this label next to the biggest one of these. And so that's that. That's 18.8. Now Zn, we have to convert the Z. Where is the Z? This Z to the Zn. Okay. And that rule is north latitudes. North latitudes, LHA. LHA, where's our LHA? LHA 320, greater than 180, Zn equals Z. Okay. North latitudes, that. So this is 122. And then where do we plot? We plot. Oh, hello, this is a note. What happened was the recording stopped completely when I was filling in this box here. And so let me just take one more minute to finish up. So this box here, this box 6, is just a place where we gather together things from the form that we're going to need when we go to the plotting sheet. So we got the A value, 18.7 minutes away from Zn 122, and we converted that from this using this rule. And then here I'm just copying the latitude, 45 north here, and the assumed longitude from right here, I'm just copying here. So this is just a last step to compile everything, so everything is simple, and we go to the plotting sheet, we just have to look at that one box. So that's the end of the video about doing a site reduction. I will come back maybe and see if we add one for the sun or planet, but this is a star.